Hello, everyone, and welcome to part two of our AI series. It is part two of two, so we are going to end here. And in this episode, I want to talk about the AI supply chain. You'll remember in episode one, we looked at the different elements of artificial intelligence, how we got to where we are, how I think of artificial intelligence as narrow, how we developed from algorithms to machine learning to artificial intelligence, and how that's going to grow into the future. Why that's so important and why I went down the rabbit hole of learning that sort of thing and learning about that industry is because from an investing perspective, I want to obviously take advantage of the new theme of artificial intelligence. So after gathering information on artificial intelligence and everything related to AI, the next step obviously is then to figure out how to take advantage of this from an investing perspective. That leads me to the AI supply chain, and I want to sort of share with you some of the insights, some of the thoughts and knowledge I've developed over time from understanding the AI supply chain, what it's about, what companies populate that universe. So that's what we're going to discuss today. Usual podcast disclaimers are on here. The content is for information and educational purposes. I may hold stocks in a professional and personal capacity. And there's one extra disclaimer this time. I'm not actually a fully tech person. So if you're sort of someone who understands every word that's said in a Linus Tech Tips video, for example, you're going to scoff at some of the definitions I use today for things like GPUs and CPUs and semiconductors. But that's fine. I think when it comes to investing, you'll realize that there's such a wide variety of things you have to start to become good at, start to understand, and you can't be an expert at all of them. But key is understanding these different industries at a certain level so that you can invest in these companies and then sort of bring these companies together. So I'm not an expert on technology, but I'm supposed to be well versed in it and be well versed in other industries too, like industrials and healthcare and utilities and sort of consumer companies, etc. So you'll see how, as we go through different sections, different elements, we start to gather knowledge on a number of different sectors and industries, and that wide breadth of knowledge is quite interesting. It's one of the reasons I joined the industry, quite frankly. So you'll see how that develops over time as we discuss different topics, and you should have already seen it as part of AI. It is an important part of AI. All right, now before I go into the AI supply chain, let's talk about supply chains in general. What is a supply chain? I made a reel on this, you might have seen it. But in general, a supply chain just talks about how we get from a final product, the end of a supply chain, all the way back to the initial stages of that product and all the different companies, organizations, businesses that line up together in different pieces to get the product from point A to point Z, which is you, the final consumer. For some reason, the example that I've always seen or read about is the wheat or bread example when discussing supply chains, where we start from pretty much seeds, but more likely we start from wheat that is growing in a field somewhere. That's the initial part of the bread supply chain. Wheat then moves over to a miller. A miller then processes the wheat into flour. That flour then goes to a baker, the third step of the supply chain for bread. The baker then bakes the bread, and then the bread then gets shipped to some sort of retailer, and that is the last part of the supply chain. So those are the 4 steps of the bread supply chain. And as you can see, every part is crucial, and those 4 steps get you from seed all the way to bread in your home. We're going to do exactly the same thing with AI. Discuss the different components and different companies that exist in the supply chain that get you from point A all the way to something like ChatGPT, which is our sort of current form of AI or narrow AI. So that's exactly what we're going to do today. The other interesting thing about a supply chain is you sometimes get things called vertical integration and then horizontal integration. Now I'll discuss this more as a reel, but vertical integration is where companies start to expand themselves into their own supply chain. For example, say I'm sort of a Pick and Pay, or if I'm using a US example, Walmart that sells bread. I might want to buy a baker so that I'm now doing the baking and the selling of the bread. I can sort of control the supply chain. And as I vertically integrate, I can own the miller, I can then own the wheat farm. You can see how it can get quite complex, but there are examples in the past of companies that have done vertical integration and owned their entire supply chain. Horizontal integration of your supply chain is where you start to buy your competitors. A classic example of that is when Facebook, social media company, bought Instagram. Instagram, growing supply chain, competitor to Facebook, definitely getting the younger demographic in. Facebook buys Instagram, and all of a sudden, horizontally, they own more of that sector. So that's how supply chains can sort of change and integrate over time. From a computing perspective, from an AI perspective, unfortunately, there's a little bit of terminology that we have to get used to here, because the core building block here is computational power, and computational power exists in all sorts of devices we have today. But let's start with a PC, because I think if we understand the building of a PC, then we can understand how the AI supply chain works, because those are the components that exist in most things that can compute and therefore do higher order algorithms, machine learning, and then AI. So the building block for any PC is a CPU, central processing unit, and that does a lot of the heavy lifting from a computational power perspective. Almost any device that can do any sort of heavy lifting, whether it be a phone all the way to a PlayStation to even TVs these days, all have some sort of CPU in it. And CPUs are just there to run a bunch of calculations. That's it. The more transistors that you can put on a CPU, and that's linked to Moore's law from the previous episode, the faster that CPU can go. So we now at a point in human technology where we can put tons of transistors onto a CPU, and I'll come back to that later when I'm talking about semiconductors. So CPU, the sort of the engine block of any computing technology. Having said that, the CPU can only do so much, and we need something to help the CPU to do even more. And this is where GPUs, graphical processing units, start to come about. And the graphical term comes up because they were put into computers to handle a lot of the rendering, the graphics, the visuals associated with things like gaming, associated with things with the visual graphical interface that we've gotten used to, the rendering and visual that we've seen with the editing of videos and the editing of pictures. All of that takes quite a heavy load. And the CPU is running a lot of processing to try and understand what the computer needs, the brain of the computer, if you want to think about it like that. So heavy tasks that the CPU can't find time to do, can't find space to do, gets handled by the GPU. So if I'm running a game, for example, has a heavy processing load, has really good graphics, really good visuals, the GPU is going to take a lot of load off, and the CPU can still run in the background, making sure that all the other parts of the computer does well, and then optimizing the GPU and therefore the game that we're playing. For example, if I do a lot of video editing and a lot of picture editing, my GPU is going to handle a lot of the work on that, while the CPU handles everything else for the PC. So as we've sort of needed PCs, tablets, phones to do more and more, we started to link GPUs and CPUs together to give the CPU more processing power on the visual end. Now, CPUs and GPUs typically don't really have their own memory. There's two types of memory. There's sort of hard disk memory that gets saved. When you click save on a document, save on a PowerPoint, save on a video, it's stored in your memory. When you put your PC on any number of times afterwards, it's still there until you delete it. That's typically called hard disk memory. Now we call it solid state memory because we have faster memory. But the thing that we care about more than hard disk memory that gets saved on and on, is random access memory. So that's RAM. And the RAM is this third component now that links the GPU and CPU and gives it a little bit more buffer, because while the CPU is doing calculations, it doesn't really save anything. It needs to sort of compute and save data into a separate place and continue to do calculations. GPUs can sometimes come with their own RAM or utilize the computer's RAM. So we have this sort of RAM that sits in the middle that sort of stores data, but it's sort of dynamic in the sense that when you switch your PC off, that RAM actually just sort of forgets everything that it's done. So it's there to dynamically give memory to the CPU and the GPU, and when they work together, the RAM can sort of support the CPU and GPU in what it's doing. Those three components together, and I know I've discussed it quickly, but those three components together will effectively get you a working computer. If you had to open up your computer, those would probably be the three main components of your PC: CPU, GPU, RAM. Why is that important? Well, if you think about it in the context of the bread example, right? You had to know what wheat does to be able to get the bread. You have to understand what the miller does to get to understand bread. So I'm now sort of filling in what the miller and the wheat farmer is in the context of computing from a CPU, GPU perspective. Because when we talk about computers that are way better, it's because CPUs and GPUs are better. When we talk about PlayStations that are better, we're talking about CPUs and GPUs and RAM that's better. When we talk about phones that are better, they don't have a big GPU in it, sure, but there's definitely a really good CPU in it. There's definitely really good RAM in it. And because these things are smaller than they used to be, we can now have far better phones than we used to have. So as much as it sounds like a little bit of a nerdy thing, you have to kind of understand the basics of this stuff, because it helps you to understand why our stuff is better, why our technology is better. But then it also gives you opportunities to invest, because there's very specific companies that operate in the AI supply chain that create CPUs, GPUs, RAM. And that's where the opportunities exist. So you can go and buy a company like EA Games, for example, because you think that gaming is going into the next level. And that's a great opportunity. Gaming has taken a lot of market share away from traditional media. Gaming is growing quite dramatically, but we sometimes forget all the things that come behind that. And understanding that full supply chain gives you the ability to be able to invest in a wide array of different companies. Okay, now when it comes to that computing power, we now also can link it into the AI episode part 1 and realize that better CPUs, GPUs, and RAM has allowed us to compute better. So that exists for the typical work case, us in our normal personal lives, us in our job lives where our computers at work are a lot better. But it also has helped to create this new world of artificial intelligence. I talked about how algorithms and machine learning were the bedrock of artificial intelligence. Without these faster processing speeds, we wouldn't be able to do the thousands and eventually millions of calculations that allows things like ChatGPTs to create their large language models. So in that idea of how Moore's law takes us from a point where we have less computing power to more computing power, this is how it's happened over time. CPUs, GPUs, RAM has all gotten better. And that is crucially important. Now, if you want to talk about the different things that these components exist in that are important for this discussion, a core part of it is computers, which we've discussed, personal devices like computers and tablets, even watches and TVs. It's in gaming consoles like the PlayStation 5, the new Xboxes, Nintendo Switches. You can now get, if you've heard of Steam Decks and things, portable, effectively computers that are gaming stations. And then a crucial part of that you probably are aware of is cloud server farms. So when you save something to the iCloud, when you save something to Google Cloud, when you save something to OneDrive, when you do computations on those servers via something like AWS, there are actually cloud farms and cloud servers that exist in physical reality somewhere in the world that is handling, processing, and storing that data. And those farms are important because I think we sometimes forget that those large processing areas that have a bunch of servers in them actually use CPUs, GPUs, and storage just like our PCs do. But sometimes when we think about the cloud, it's like this thing exists in the ether. But when we're saving something into the cloud, it is actually going to physical property somewhere in the world where a Google or a Microsoft or an Apple has actual physical server infrastructure that it is using. And that's crucial to understand because in those server farms, we have the same building blocks that we talked about just now, just like we have in our personal computer at home where we might be saving specific data. So you can see how as the computing technology has gotten better, they've permeated our entire lives. Almost every single device in our natural world, from a technology perspective, now has some sort of CPU, GPU in it. I mean, TVs back in the day didn't, but now a TV has a CPU, GPU, therefore an operating system, so it can link to the internet and things. Fridges even have CPUs in them now, the ones that have these sort of screens where you can interact with them. Our watches have a CPU in it, which is incredible. Any number of devices, those Alexa devices, Google devices that talk to you and things. Our cars have CPUs in it. So the technology revolution from that perspective has allowed us to really push technology into all parts of the consumer landscape. But let's get now into the supply chain itself. And I want to start at the end of the supply chain, so the bread section, and then go all the way back to the different components to see how we get all the way back to the farmer effectively. So the last part of the AI supply chain is software companies. Okay, so when we think of software, you can think of things like the Microsoft operating system, Office, for example, right? You can think of companies like Adobe that do photo and video editing effectively. You can think of gaming companies like EA Games that I mentioned, or Take-Two Interactive that via Rockstar make Grand Theft Auto. You can think of ChatGPT as an example of software. How better computing and the race to AI has helped these software companies is that they've allowed them to become way better than they were in the past. Think about something like EA Games. If you're a FIFA fan like me, and you think about FIFA back in 1999, which is when I sort of started playing FIFA, the gap between FIFA 99 and FIFA, say, 2024 is amazing. How have we gone so far in terms of graphics and playability, etc.? It's because computing has gotten better, and then EA has been able to make that game better. How has Adobe been able to get better and better in terms of developing new software associated with photo and video editing? It's because computing technology has gotten a hell of a lot better. Why can Microsoft now link all of their systems via OneDrive? It's because computing power has gotten better. So the effect of better computing in society has meant that we could create ChatGPT, we could have better games, we could have better software. So software companies are definitely benefiting. If you think about the fact that software in our phones can now do so much. I mean, you can do mobile gaming, for example. You can view Netflix on a phone, which you couldn't do sort of 5 or 10 years ago. You can have full cloud integration into a phone. If you think about how good a phone is at capturing photos and videos, it is amazing. All of that software enhancements comes because of better hardware, and that hardware is helping to create things like AI. So software companies, final ring of the supply chain, have benefited. We go one level up, and the technology hardware companies are creating the platform for these software companies to be able to do what they do. So that is the next leg of the supply chain. And when I mean hardware companies, I'm talking Apple, for example, which creates the iPhones, the iPads, the MacBooks. Because that hardware is getting better computers, better tablets, better phones, it means that companies like EA can put out better games on those devices. When we think about the Sony PlayStation 5, for example, we went through iterations of PlayStation 1 to PlayStation 5. The PlayStation 5's better hardware, therefore FIFA can work better on it. Okay, and that's come because of this dramatic increase in computing technology. And when we eventually get something like ChatGPT, which we use on a PC, it's good because the hardware of PCs is better. But more than that, it's good because cloud computing is better. When I think about cloud computing, I think about it as hardware. It's the server farms I talked about just now. ChatGPT works obviously online via those server farms. So when we ask it for things like, give me a meatball recipe, those computations are happening in a server farm somewhere, and the training of ChatGPT over time happened via these servers, these high-end computers, these supercomputers, which is then storing data in an off-site place. So that's hardware that's gotten better, the next leg of the supply chain. Better computers, better phones, better PlayStations, and now those cloud computing server areas that we now have in the world. But now we're getting to the nitty-gritty, right? This is why I talked about CPU, GPU, RAM, because inside the hardware sits the CPU, the GPU, the RAM. In a normal personal computer, that makes complete sense. You have a CPU that does the computations, GPU that handles things like rendering and gaming, and the RAM that sort of gives you some random access memory or some dynamic memory over time, right? But that also exists in your phone. It's exactly the same setup. CPU, small GPU, RAM exists in a phone. PlayStation, small CPU, small GPU. In fact, they're sort of combined in something called a system on chip, an SoC. And that has RAM associated also and a hard disk drive, So even a TV, for example, doesn't have a GPU but has a CPU in it, has a little bit of RAM, doesn't really have a hard disk drive, which is why you can't sort of save things on your TV, But all of these devices are using these these building blocks of PC in it, which is why we need to understand the companies associated with it. And I'm going to split them out into GPU companies, CPU companies, RAM companies. Okay, the most famous GPU company, and most of you should have heard this name now because it's become so topical, NVIDIA. NVIDIA makes GPUs. They're called the GeForce GPUs. They're used all over in gaming. They're very high end. They interact very well with certain CPUs, which we'll discuss just now, and give your computers a lot of computational power. So if you're a high end gamer, you probably have a GeForce graphics card in your computer. If you do video and song and picture editing, you probably have a GeForce graphics card to help you to render those things. But it even extends further than that, because a GPU, even though it has graphical in the name, is all about computational power. So for example, Bitcoin, the generating of Bitcoin, is all about letting your computer find the cryptographic hash. And if you find the cryptographic hash between two transactions, you get paid via Bitcoin, right? We'll get into it in a Bitcoin episode, I promise. But that's a brute force calculation. Your computer just runs this calculation over and over to try and find a code effectively. And you need a lot of computing power for that. The more computing power you have, the quicker you can find the hash. So GPUs, even though they have graphical in the name, were used for Bitcoin. Exactly the same for server farms. Okay, that when you send something into AWS, Amazon Web Services, or OneDrive, or Google, they have server farms that have CPUs and GPUs that are able to crunch data for you if you need that, or handle your storage for you, and therefore you need GPUs for that. So like I said, NVIDIA, probably the most famous GPU company. The other is AMD. They have the Radeon graphics cards. AMD is more known for their CPUs, and companies can exist in this world where they do a couple of things. That's that vertical and horizontal integration I talked about. But NVIDIA is sort of more core in the GPU space. AMD does GPUs as well as CPUs. Those are probably the two most famous ones in the GPU space. If we flip over to CPUs, central processing units, so you have AMD, which I talked about, and that company's gone through quite a resurgence under a new CEO. If you know anything about computers and the new Ryzen CPUs, the 357s and now onwards, they're very good CPUs now. And AMD's share price has actually skyrocketed on the back of really good CPUs, really good GPUs, but in particular CPUs. The other stalwart of that industry is Intel. So if you have a PC and if you see a little Intel Inside sticker on it, i3, i5, i7, that's referring to the CPU and the CPU power you have inside your computer. So Intel has been around for decades, probably one of the initial creators of CPUs. And that company's gone from strength to strength, still develops very strong Intel chips, but it's actually falling behind a little bit now because they always created their own chips from scratch, and they're falling behind because companies like AMD are catching up thanks to new players in the supply chain. We'll get to that in just a second just now. So Intel, crucial CPU developer and has been for many years. AMD, a company that sort of lost its way but is now coming back quite dramatically with the Ryzen CPUs. Those are more your sort of computer, PlayStation, bigger format device CPU companies. But if you think about our phones and tablets, they need smaller CPUs, more specific CPUs. That is handled by a company called Qualcomm. So Qualcomm pretty much make all the CPUs that go into most of our phones. Samsung also makes some CPUs that go into their own phones, but even they've switched over to Qualcomm CPUs pretty much for the entire world. So if you look inside a Samsung phone, all the iPhones, Qualcomm CPUs are sitting inside. Apple's obviously moved over to their own CPUs now, the Bionic chips, which we'll talk about in a second, also in the context of the supply chain. But by far and large, most of the CPUs inside cell phones are Qualcomm. So you've got AMD, you've got Intel, you've got Qualcomm, that are probably the most important CPU companies as part of the supply chain. And then you've got the RAM companies, which is kind of like your base hardware, the memory stuff. And there's two companies there, Micro and SK Hynix. Micron and SK Hynix. And those are sort of crucial companies, bedrock companies, but less exciting companies. RAM is not really the exciting part of the computing landscape, so we generally focus more on CPUs and GPUs. Okay, now we get to the really important part, and a part where a lot of people haven't heard about, and that is semiconductor foundries. Because when it comes to CPUs and GPUs in particular, the building block inside them are semiconductors. A CPU is made up of semiconductors, GPU is made up of semiconductors. And there are semiconductor foundries that effectively create these CPUs and GPUs for you if you give them a design that you would like. This is very different to the past. So someone like Intel, for example, 30 years ago when they effectively started doing this, had the entire supply chain locked up for CPUs. They would do the design, they would manufacture that CPU, and they would then sell it to the end consumer. Okay, so they kind of control the entire landscape. It's the same with Qualcomm in the phone CPU space, and that's sort of how the architecture worked. Eventually, there came a point, though, where foundries were created, and the most famous one right now is Taiwan Semiconductor, which sits out in Taiwan, that said, look, you know what? If you have a design for a CPU, we have the technology to create via semiconductors your CPU. And we actually, from a technology perspective, have gone so far that we can create even smaller CPUs with a lot of computing power on it that you can sort of just buy from us. You don't need to create the technology around manufacturing. Extending the supply chain out a little bit. Intel, which owned the entire supply chain, benefited from that. But companies could now go, well, I have a design for a CPU. I don't know how to make it necessarily, but I have a design that's going to fit in a specific phone or a specific laptop or a specific PlayStation. Can you, Taiwan Semiconductor, a semiconductor foundry, make that for me if I know what I want? Taiwan Semiconductor goes, yes, we can, and we'll get that to you. And that has resulted in a monumental shift in computing. The Bionic chip that I talked about from Apple, that is effectively created by Taiwan Semiconductor, designed by Apple. Qualcomm has a number of chips that's now being created by Taiwan Semiconductor. AMD's chips are now being created by Taiwan Semiconductor, and they're now therefore competing with Intel in terms of processing power. Taiwan Semiconductor went on a massive, large-scale project and a lot of intellectual property or IP, and spent a lot of research and development money on making thinner and thinner and thinner and smaller CPUs. We call those wafers. So they're sort of putting circuits onto wafers, and we talk about them in terms of nanometers. And in terms of nanometers, we've gone from sort of the high double-digit nanometers to now Taiwan Semiconductor being able to create 7 nanometer chips and then 5 nanometer chips, and we now have 3 nanometer chips in the offing. And if you know anything about computing from the first episode, we know that the smaller your chips can go, the more computing power you can put on them, the Moore's law effect takes over, and we can have better and better computing in more and more products. Not only that, we can get smaller in terms of getting better computing power in smaller devices. So if we think back to the end of the supply chain, our phones are better, our computers are better, our tablets are better, our watches are better, because Taiwan Semiconductor is on smaller and smaller wafers putting circuits, and they're sort of giving that out for a price. So now you don't have to be an Intel with 30 years of R&D and IP. You can be an AMD, which has a design in mind, and then creates via Taiwan Semiconductor. It's absolutely changed the game, created another layer in the AI supply chain that a variety of companies are taking advantage of, and companies that we interact with every single day, if you think about Apple, etc. I could have ended there. So everything that I've talked about so far is a full project in understanding how we got to ChatGPT, why our computers are better, why Microsoft is doing better as a company. It's understanding the software, the hardware, what a CPU, GPU is, who creates those CPU, GPUs, taking it one step further. How has the industry changed with the introduction of foundries like Taiwan Semiconductor? But whenever you sort of get into things like supply chains, the more laterally you can think, the more you can extend it out, the more you can have a benefit from doing that work and understanding these things better. In the context of the bread example, you could have stopped at the wheat farmer, right? But there might be a seed producer that creates very specific seeds that grow in better climates, etc., and that seed producer could sell to the wheat farmer. So that the start of your supply chain might be one layer back from where you thought it was. And if you've put in all this work to understanding the supply chain at this point, the more you can extend and think laterally, the more you're going to benefit from all the work you've done from just an understanding perspective. So that's what we did. We went one level higher, so above the foundries, there's a company called ASML. And I mentioned one company because they're basically a monopoly in this space. They create something called an EUV machine, and you can look up what EUV is. It's extreme ultraviolet light, effectively. The machines are called photolithographic machines. They effectively use short wavelength light bouncing off mirrors to etch extremely specific designs onto wafers. So if you think about something like Taiwan Semiconductor and Intel, they would use an EUV machine to actually etch onto a wafer. But they don't create that machine themselves. They buy it from ASML. Now, there are companies that have etching tools that you could use, but the EUV part, the ultraviolet short wavelength, bounced off mirrors, that kind of etching, it gives you very precise etching. And ASML owned the technology and how to create those machines. The machines cost hundreds of millions of dollars to buy just one. But if you think how important foundries are and how crucial computing powers are, how important computing power is to us, you can understand how this sort of high-end equipment is well worth the asking price. And in fact, foundries are popping up all over the world, and ASML is selling the EUV products into them. So when Taiwan Semiconductor was sort of created, to compete with Intel, who started way before, you had to bring in significant technology to be able to etch onto smaller and smaller chips to even compete with Intel. And that's what ASML created for Taiwan Semiconductor. So those EUV machines are sitting inside Taiwan Semiconductor. So we had to understand the EUV technology, the lithographic technology, how short wavelength worked, how the mirroring worked, how that would make Taiwan Semiconductor be able to make smaller and smaller nanometer chips because they can be more precise with etching. How if a new foundries exist that basically sold this IP onto companies, how Apple would be a hell of a lot better as a company because they could create their own CPUs and vertically integrate. How the likes of Qualcomm could create better chips for smartphones, etc. You can see how all of this starts to integrate together. And if you follow it from ASML through Taiwan Semiconductor all the way through cloud server and the ability to then run better algorithms, better machine learning tools, you will get eventually to ChatGPT. And that is the AI supply chain. It's incredible how we've gotten here so quickly as a society. It's incredible to see how the supply chain for technology has changed. I think it's crucial for us as individuals to understand this technology better, to understand the components of the technology, not just from an investing perspective, but from a social perspective. And hopefully this episode gives you a background now to work from. I've heard a lot of episodes about AI. They're all over the place, but I haven't heard many episodes on this level of supply chain talk and understanding the companies in the supply chain. I, of course, use it from an investing perspective. But I think it's important that we put it out there because this knowledge is useful because we use these things every day. ChatGPT, things like Facebook, Microsoft, gaming inside PlayStations and things. But we seldomly take the time to figure out why these things exist and how they exist. And hopefully for those of you sort of are interested in this sort of thing, this has given you the information that you need. As always, if you made it to this point, thank you very much for tuning in. This podcast is available on YouTube, it's on Spotify, Google, Apple, so find it wherever you want to. We have an Instagram channel and TikTok channel where I'm going to be putting out reels on this episode, fleshing out a couple of different ideas, etc. We plan to come out with more episodes on different ideas. I started by talking about companies only, but we realized that we wanted to extend that out into different ideas around different subjects relating to finance, investing, and the wider world because they're all sort of interrelated. So hopefully you're enjoying the content and you stay tuned. If you did enjoy it, like and subscribe on YouTube. Follow us on the podcast channels. Leave us a comment and a review. We really appreciate it. Thank you so much for joining us for another Impact Co podcast. Cheers.